The last known thylacine died on September 7, 1936, in a Hobart zoo. The keeper had already gone home. Nobody was watching. The species was officially gone. And then the sightings started. Over 3,000 of them across 90 years. Photographs that experts cannot definitively explain. A 60-minute segment in 2024 that treated the possibility of survival seriously enough to air in prime time. And a company in Dallas with a 99.9% complete genome and a 5-year reintroduction timeline that is not waiting for the sightings to be confirmed. The thylacine is coming back. The question nobody is answering is what Tasmania does when it arrives. Part 1. The night it died and why nobody accepted it. September 7, 1936, Hobart Zoo. A thylacine named Benjamin, though recent research suggests it was likely female, paced its enclosure through the afternoon. The weather was cold. The keeper had locked the animal out of its sheltered sleeping area by mistake. By morning, it was dead. Exposure. There was no ceremony, no documentation of the moment. The species that had roamed Australia for millions of years, that had been systematically hunted to extinction over a few decades by European settlers who considered it a threat to livestock and paid bounties for its carcass, ended in a concrete enclosure on a cold Tasmanian night while the keeper was elsewhere. Australia declared the thylacine extinct 50 years later in 1986. 50 years of official uncertainty before the government was willing to put the date on paper. And in that 50-year gap, the sightings began, and they never stopped. The reports are not fringe material. They come from park rangers, farmers, wildlife biologists, and police officers. They come from the Tasmanian interior and the mainland in Papua New Guinea, where thylacines also once lived. A 60 Minutes Australia segment in April 2024 treated the possibility of a surviving population seriously enough to investigate it on camera. Wildlife biologist Forrest Galante published photographs in May 2024 that he described as potentially legitimate while remaining appropriately skeptical. Over 3,000 reported sightings since 1936. Not confirmed, not disproven. The animal that was supposed to be definitively gone has spent 90 years refusing to fully leave, which creates an unusual situation for a de-extinction program. Colossal Biosciences is building a thylacine in a lab in Dallas, while people in Tasmania are still reporting seeing one in the bush. The scientific community is not taking the sightings seriously enough to suspend the program, but the cultural weight of those sightings is part of why the thylacine is the de-extinction story that resonates most deeply in Australia. The animal never fully died in the public imagination, which means what Colossal is building does not feel like resurrection to Australians. It feels like confirmation. Part 2. What Colossal is actually building. The thylacine program started in 2022 in partnership with Andrew Pask's lab at the University of Melbourne. In August 2025, Colossal acquired the lab entirely, bringing Pask in-house as Chief Biology Officer. The most important thylacine researcher in the world is now a Colossal employee. The genome is 99.9% complete. Reconstructed from a 110-year-old preserved skull. The most complete ancient genome ever assembled for any species. The closest living relative is the fat-tailed dunnart, a small marsupial mouse-like animal. The dunnart serves as the genetic foundation and the surrogate. Its gestation period is 13.5 days. Compared to the mammoth's 22-month elephant gestation, the thylacine program moves fast. Marsupial reproduction is the specific technical challenge that separates this program from everything else Colossal is doing. Marsupials are born at an extraordinarily early developmental stage and continue growing in the mother's pouch. The embryo that implants in a dunnart surrogate will be a thylacine embryo, completing marsupial development in an animal the size of a small mouse. The size mismatch between dunnart and thylacine, the thylacine weighed up to 30 kilograms, means the surrogate pathway requires engineering that the mammoth program, despite its longer timeline, does not face in the same form. Colossal has created marsupial-specific induced pluripotent stem cells, a world first. The reproductive technology for marsupials that did not exist before this program exists now because
this program needed it. The Tasmanian Thylacine Advisory Committee,
A 15-member body including local government representatives, Aboriginal Tasmanian community members, and conservation stakeholders was formed in December 2023 to manage community coordination for the reintroduction. The committee chair has stated publicly that a 5-year reintroduction timeline is possible given the pace of progress. That puts living thylacines in Tasmanian wilderness by 2030 or 2031 if the program holds its schedule. 5 years. The animal that died in 1936 could be walking through Tasmanian bush in less time than it takes a child to complete primary school. Part 3. Why Australia needed it back. Australia has the worst mammalian extinction rate in the world, not in the last century, in recorded history. Since European settlement, the country has lost more mammal species than any other nation on Earth, and the losses have not been random. They have followed a pattern. Remove the apex predator. Watch the prey species expand. Watch the invasive species that were held in check by the prey species' behavior expand further. Watch the vegetation change. Watch the fire risk increase. Watch the cascading consequences move through the ecosystem in ways that take decades to fully reveal. The thylacine was Australia's only marsupial apex predator. When it disappeared, the island of Tasmania lost the animal that regulated its mesopredator populations: the eastern quoll, the spotted-tailed quoll, the feral cat, the fox that has been slowly colonizing Tasmania from the mainland. Without a predator above them in the food chain, these animals expanded into behavioral patterns that the ecosystem was not built to sustain. Colossal's own materials describe the ecological consequences of the thylacine's absence directly. Without an apex predator, ecosystems experience trophic downgrading, the spread of disease, an increase in wildfire frequency, a reduction in carbon sequestration, a disruption to natural biogeochemical cycles. The thylacine was a keystone species. The keystone has been missing for 90 years, and the arch above it has been slowly collapsing in ways that the available conservation tools have not been able to reverse. The ecological argument for bringing back the thylacine is the cleanest in Colossal's entire portfolio. The habitat still exists. The prey species still exist. The island is still there. The gap the thylacine left is measurable and documented, and currently getting worse. Every other de-extinction on Colossal's list has complications. The thylacine's ecological case is almost straightforward, almost. Part 4. What Tasmania forgot. Here is the part that does not appear in the announcement. The prey species in Tasmania have spent 90 years without a thylacine. The wallabies, the patamelons, the bedongs. Their behavioral responses to predation pressure from an apex predator are not instinctive in the way that fear responses to known predators are instinctive. Fear responses to specific predators are learned and culturally transmitted through populations. Young animals observe the behavior of older animals and build their threat library. The threat library of every prey species in Tasmania has been missing the thylacine entry for 90 years. When the first thylacines are released into Tasmanian wilderness, the prey animals they encounter will have no evolved behavioral response to them. They will not recognize the threat signal. They will not know to run at the specific distance that makes a thylacine hunt successful or unsuccessful. The first generation of interactions between released thylacines and Tasmanian prey will be a behavioral experiment with no baseline and no precedent. This could resolve quickly. Prey animals learn. Populations under new predation pressure adjust their behavior within generations. The thylacine's reintroduction might produce a trophic cascade that reshapes the ecosystem in positive ways within decades. The Yellowstone gray wolf reintroduction produced changes nobody fully predicted, and most of them were considered beneficial. But the thylacine itself is the other half of the problem. The animal Colossal produces in its Dallas facility has no behavioral inheritance. It cannot learn hunting strategies from a parent thylacine because there are no parent thylacines. It cannot observe how to select prey, how to use the specific terrain of the Tasmanian Southwest, how to manage its energy across the specific seasonal patterns of the island. That knowledge was transmitted across generations of wild thylacines, and the last of those generations died in 1936. What Colossal is releasing into Tasmania is a genome. The behavior that should accompany that genome has to be constructed from scratch. From observations of the Dunnart, from what the limited historical record of thylacine hunting behavior shows, from what comparative carnivore ecology can infer, from what happens when the animal meets the actual landscape and starts making decisions in real time. The Thylacine Advisory Committee exists partly to manage this. The plan includes staged release protocols, habitat preparation, monitoring systems. It is not a situation where Colossal opens a crate and walks away, but no monitoring system fully predicts what happens when an animal with no behavioral inheritance meets a prey population with no fear response in a landscape that has been reorganizing itself around the absence of both for 90 years. That is not a reason not to do it. The ecological case for the reintroduction is real, and the absence of the thylacine has caused documented harm for nearly a century. It is a reason to be specific about what is being attempted, not a restoration, an introduction, of a genetic approximation of an animal into an ecosystem that has changed in its absence, with behavioral unknowns on both sides of the encounter that no laboratory can fully resolve before the release happens. The thylacine sightings have been running for 90 years because people wanted the animal to still be there, not because of what it was ecologically, because of what losing it represented, the systematic human destruction of something irreplaceable. The bounty programs. The last animal dying alone in a concrete enclosure while the keeper was elsewhere. The thylacine became a symbol of a specific kind of guilt that Australia has carried for nearly a century. Colossal is building a response to that guilt in a lab in Dallas. 5 years from now, if the timeline holds, that response walks out of a crate into Tasmanian bush and starts trying to figure out what it is and what it is supposed to do. The genome will be close to right. The animal it produces will look like a thylacine. It will move like one. It will hunt like one, eventually, through trial and error and the specific pressure of needing to eat. And the ecosystem around it will slowly, over years and generations, rebuild the relationships that the original animal anchored for millions of years before a government bounty program ended them in a few decades. Whether that process looks like restoration or like something stranger and more complicated depends on decisions that have not been made yet. The behavioral protocols, the release location, the monitoring framework, the response plan for outcomes nobody predicted. Tasmania has 5 years to figure out what it thinks about all of this. The animal is not waiting for the answer. It is being built right now. If the story of how this program fits into what Colossal is building across 6 species and what it could all go wrong is what keeps you watching, our last video is the one that covers the red wolf story everyone missed. Watch The Real Win Was Never the Dire Wolf next. Buried in the dire wolf press release was a conservation achievement that should have been the headline. 4 cloned animals, a 25% genetic diversity increase, and a living species getting closer to the edge while everyone watched the dead one.